Yeah. All right, welcome to our May technical meeting. Thank you guys for joining.
Hey, Turner.
Yes, sir.
This is Matt Dalton. We're out here in Tennessee. We got Blake and Tim from Tennessee here with us. They'll be listening in.
Welcome, Blake and Tim. Yeah, Dalton and Jesse Wade are out in Tennessee, did you say? They're out of state right now, and the folks that are with them are going to join us and just kind of observe today. You guys are welcome to make any comments as we're going along or ask any questions. So here's the agenda for the meeting today. I've got just a couple of training things I want to talk about and just our normal production update. I have two things that people from the field have brought to my attention, and I just wanted to pass them along to the group. Some tools that may help you guys. And then our main topic for today is going to be two things. The guys from Bragg are actually going to share what they've experienced with this new hybrid water heater that they've been installing. And we'll take a little bit of time so you guys can ask some questions there. And then we've also got a new worst case draft form that I want to share with you guys, and then we'll kind of push that out in a draft form, give you guys a little bit of time to work with it and make sure that the new form actually works. So that's the outline for the meeting today. Does anybody have any questions or concerns about anything before we jump into it? All right. So the training opportunities, as Bolander mentioned a minute ago, he was asking about the energy auditor class. There's just 4 seats in that class, so a few of you should be aware of this, but our class is, I think, next week, so May 13th through the 16th. I did work with Wade yesterday, and we put another class, so the next BPI Energy Auditor class, this is the full class, this is the 4-day class where you come to class for 2.5 days, and then there's time to test at the end of it. If you just need to recertify, just work directly with Wade, and they'll kind of schedule a specific time for you. But if you need to take the class for the first or second time so you can pass it, then the next time we're going to offer it is September 16th through the 19th. There are 2 people that have submitted letters but did not make the May class. So that would be Zach and Brandon. I don't know if you guys are on the line or if your coworkers can let them know. If you guys will just confirm that those dates will work, the September 16th through the 19th, then you 2 will get the first 2 seats in that class. And then we're looking for 2 others. So basically the first 2 people that submit a approval letter from BPI, then you'll get the other 2 seats for that class. So any questions on that? All right. The other training opportunity is, I don't know if you really even dare call it training, but last year we had a class where we all got together and we kind of went through our setup library and just made sure everything was in order going into program year 18. If more than one representative wants to attend this, we can do that. It's really not that big a deal, so it is a good learning opportunity. But we need to hold a session where we actually sit down and set up our fuel library and, more importantly, our measure life adjustments for program year 19. And I think I mentioned this last month, but what this is the folks from Energy Out West, they felt like some of the measure lives in the audit tool were not long enough, that some of the insulation measures really last longer than 20 or 25 years. So they were able to work with DOE, and DOE said, okay, we'll approve longer measure lives on some insulation measures. And then in order to allow our state to do that, we had to submit kind of an application to them and show them how we would do it. Long story short, each agency has to put some specific things into your audit setup library so that those measure lives will now be longer than 25 years. And it's specific enough that I'm thinking we'll start as a group, and then if anybody has any additional needs, I can work with you one-on-one. But we have committed to DOE that we will make sure that each agency gets these setups or these settings correct before July 1. So I'm really looking for your feedback on this. Basically wondering, do we want to meet at the IWTC? Do we just want to do it as a webinar? If there's a mixed bag, we could probably do both. I anticipate the fuel library and the measure life adjustments really taking about 2 hours, but if any agency needs more time or wants to work in more detail on other setup library stuff, we could do that. Anybody have any strong feelings on this or want to do it a certain way?
Webinar sounds kind of good.
Okay. And what I'm looking for is I need one representative from each agency to attend, and that person just needs to be the someone who can actually, has some experience with the setup library, and they'll kind of be setting up the official setup library that will need to go into effect on January 1. But I will plan to be in person at the I will be up at the training center at IWTC. Hang on. Brandon, if you are not trying to speak with us, we can mute yourself. Thanks, man. Yeah, anyway, I'm going to hold the session at IWTC. I think if anybody wants to attend live, they can, but I think we'll do a webinar. If I hear strongly one way or another, we may modify that, but put that on your calendar. I will be reaching out directly just to coordinators to get a commitment of one person from each agency to attend on June 11th, and unless we have any major schedule conflicts with that date. So anyway, is anybody aware of any other training opportunities that the group should be aware of? Those of you who are the actual qualifier for your contractor license at your agencies, you should be getting a bunch of emails right now about different CE, like continuing education classes that are available. But just a reminder again, all your continuing education and your recertification for your contractor license is due this fall, so make sure that you're staying on top of that as well. So anyway, let's get on to new business. The next technical meeting will be June 4th. I will probably be away for that one, so Wade or Dalton will be in charge of it. But put that on your calendar. Our production, just our normal production update or review. This is where we're at on things. So the light green is what our goals were. So on the left-hand side here, each agency set a goal for each month. So we took every agency for April, and one agency might have had a goal for 7, another one had a goal for 10. We added all of those goals up, and every agency had a goal to get a total of 49 units. And in April, we got 47 weatherized units completed. So thank you guys for all of your hard work. As you can see, we've fallen short in other months, but it was nice to get really close to the goal this month, and we appreciate all that you've done for that. And then over on the right, you can see this is we added up all of those goals and kind of turned it into a running total, which would get us to where we need to be at the end of the year. And as of the end of April, we are falling short of where we need to be. We if we were on track with all of our goals, we would have 447 units, and we're at 328. So each of you have smaller goals that need to be, worked towards and hopefully accomplished before the end of the year. But just my normal spiel, we really do appreciate everything that you guys are doing in your own respective responsibilities to help accomplish these goals. And then anywhere you can find opportunities to do a little bit more to increase efficiencies will definitely help us to work toward our production goal for the year. So crisis and total client served. So on the left in light blue, we just took an average of all of the crisis jobs over the last 4 years, just to get some indication of where we normally are. And then the dark blue, which is in the front, those are the crisis completions we've actually had for the year. And so you can see there is an upward trend. What's that?
I can't see that graph. I can't see that graph.
Okay. Are others having similar issues? Oh,
there we go.
I suspect you may have a bit of a delay. Is anybody else having an issue with that?
No issue here. We're good.
All right.
My bad.
No, it might be a connectivity issue. But if anybody else is having issues, speak up. Let me know. Anyway, yeah, on the left we've got the crisis completions, and as you can see, we are getting more and more crisis completions. I do still believe that a big part of that is because we're now reporting more crisis. We're kind of breaking the different things down, crisis water heater, crisis furnace, so that we're actually turning in more BWRs. And that's why we've been tracking the number over here on the right, which is our total clients served, just to keep our bearings on how many people we're actually helping. So the total clients served, that's an unduplicated count of all the clients that we've helped in the last 5 years. The light purple in the back is kind of the 4-year average, and then the dark purple in the front is what we've been doing this year. And so as you can see, we've actually served, on average in April, we served 49, and this last month we actually served more clients than we normally do. And I think that is kind of a good indication. If we are serving more than we normally do, then it should in turn into additional weatherization completions. So anyway, but that's kind of where we're at with production. Anybody have any questions on that? All right. As I mentioned earlier, I just had a couple things that I wanted to share with you guys that have come from the field. Burl Kinoshita out of Utah County, he has shared this. What this is it's a app that will basically take the photos that you've taken and kind of put them into a PDF for you. It's an Apple app, so if you're using an Apple device to take photos, whether you're an auditor, QCI, or production, or whatever, this is a handy tool that will quickly convert those photos into like a couple of page report. In fact, let me see if I can pull up the report that Burl shared with me. I thought it looked really nice. So I'm just going to scroll through it. So this is what the app spit out. So it just had a nice cover sheet. It's got a cool spot where you can basically add a caption to each photo. And it lays them out quite nicely. So anyway, just something you can look for. I found it pretty easily by just simply searching for the PDF photo in the Apple Store. So anybody tried this, feel like it worked well, or found anything else that works good that's similar? All right. And then the other thing was I wanted to share this from Bragg. I was talking with Jesse Waite last week, and I know I've had questions from a few of you about HRVs, and I'm aware Jesse and the guys up in Logan have installed a few HRVs. So I was just simply asking Jesse, what HRV are you guys using? And he gave me this information. And then he also shared kind of a guideline or a rule of thumb that they use that I want to share with you. But this is the HRV that they're using. They're buying it from Johnstone. It's somewhere around $800 or $900. And it's a Honeywell. It's called the True Fresh. And it will move, depending on which model you grab, it'll move 150 to 200 CFM of air. Obviously, the installation is a little bit, you've got to run an intake and an exhaust. And if there is interest in this, we could, if you guys will reach out to me and let me know what the level of interest is, we may work with the guys at Bragg or another agency that has installed some of these, and we could try and put together some more info or a little video or something to help any of you guys who are dealing with these on a regular basis. So, but the other thing I wanted to share with this was this, they have kind of this rule of thumb that they use when they're thinking about their ASHRAE strategies. And I thought it was a pretty good rule of thumb. This is not the state's guidelines or anything. I just wanted to share it with you because I thought it was very helpful. In general, if a house needs less than 35 CFM of continuous air, they will try to address that with makeup air. And the reason they do that is that at 35 CFM, that is going to run the air handler at just minimally. So most of the time, just when the air handler runs to heat or cool the home, that will give them enough ventilation. And then there's, minimal additional, so they don't have those client complaints about the air handler running all the time. Whenever they need 36 to 100, they'll address it with exhaust. And then if they need more, if they're 100 to 150, and if the home has a subspace or a basement, they do not install the HRVs in an attic because the clients will never go up there to maintain them. But so, the stars have to align a little bit here, but when they need that much, they'll look at doing an HRV. So just thought that was helpful. With this HRV, there was one other thing I want to point out, and that is, so this HRV, right in their brochure and stuff, it says that it meets the ASHRAE 62.2 standards. I just went through their literature. I didn't reach out to Honeywell at all, but I could not see anything in their literature that talked about the SON rating. I'm assuming that the way that this meets the ASHRAE standard is through the sound rating exception. And the exception is, any of the fans that we're using for the continuous or the whole house ventilation, they have to be below 1 SON, or they can be an air handler or a remote mounted fan. And so if you're doing an HRV, just remember, if it's going to meet ASHRAE, either the manufacturer has to say that it passed the SON test, or you're going to be installing it as a remote mounted fan. And just the ASHRAE standard says, to be considered for this exception, a remote mounted fan must be mounted outside the habitable space, and there must be at least 4 feet of ductwork between the fan and the intake grill. So anyway, and that's really, the stars kind of have to align sometimes for that to happen, because an HRV does have filters on it, and it does have maintenance more than other options. So the client needs to be able to access it, but it also is probably going to have to be a remote mounted fan. Is anybody aware of any SON ratings on HRVs at all, or do they typically go in as a remote mounted fan?
They go in as a remote mounted fan. They're not, but even still, they're not that loud when they're running.
Gotcha. Thank you for that. And with that, so this is Mark from Bragg, and if you're ready, Mark, I'm gonna turn some time over to you, so so you can tell us a little bit about this hybrid water heater that you guys have had a little bit of experience with. And for those of you who are listening as Mark's talking, please ask any questions. If you want to ask them out loud, or if you want, I'll kind of keep an eye on the chat and I'll help field some questions. So yeah, Mark, tell us what this is, why you guys started looking at it, and what your experience has been with it.
So this is the HTP crossover water heater that we've been using. The reason why we started looking at it is a lot of our power direct vents, none of them that we can find are good to put in a manufactured home. That was one of our main things. And this one has manufactured or mobile home approved, but at the same time it also helps, and it's cheaper for us. It's only $1,300 versus the new low NOx and compliant and all that that's coming out. You're right around $1,600 to $1,800 for one of those water heaters. And then also when we do have a water heater that doesn't pass worst case anymore, and they fit in more room. They're little. They're only 20 gallons, but they heat the water up to, I want to say the new models heated up to 160. And then on them, they also have a mixing valve that's set from the factory for 120 degrees. And so it takes that out, but I have a couple that has nothing to do with Bragg, but I've installed in other places, and it also has helped their gas bill go down. There are a few things that you do have to look at it. Its input it's high. It's a fully modulating, so its high output is 76,000. So in houses, typically water heaters are set up for 40,000 BTUs. So you do have to look at that before you can put them in. They put out a lot of condensation. They have a high volume of it, so it's something to consider using under a mobile home. If it's going to be a problem, if you have a if it's high use. Past that, we've had good luck with them.
Yeah, so here's some photos of the installs, and that's just a picture showing that they are mobile home approved. And then just a couple of different installations. You said you installed one in your sister's home, and she's had a good experience with it so far?
Yeah, so the picture on the left is the one of my sister's house, and I wouldn't recommend, as you can see, in that picture, the expansion tank. I wouldn't recommend doing it like that. That one is actually, since then, is getting changed. I would remote mount the expansion tank to the ceiling or to the wall, not like that. The connections on top aren't like a typical water heater, because there is all the mixing valve and stuff behind them.
So this is just
picture on the right.
Not very stable spot to connect those. Is that right? Okay.
Yeah, but the one on the right, I remote mounted the expansion tank somewhere else, and they're low. they're low to the ground. They don't take up a lot of space. The one downside to them that we see is condensating versus the other power direct vents. You don't have to.
Yeah, I noticed mine has very little condensation, but this I noticed in the literature has a high volume of condensation. And then you mentioned how you ended up mounting this condensation pump like directly below it. What was going on with that?
So originally on this picture on the left, I had just ran some vinyl tubing from because it has a condensation trap under, and took it over to the drain. But the water staying in that vinyl tubing backed up and it will leak. The best thing I've found is to come straight off, drain it, and get it away from the unit instead of letting it build up there.
Gotcha. That, like, instead of, you originally did it as like a gravity fed, so it was just draining over to a drain, and that wasn't working?
Well, the drain's farther away. I had it drained gravity fed over to another pump.
Oh, gotcha. And it was
furnace, and it was backing up and leaking. It was putting out probably about leaking a gallon of water a day. But then I put this pump in, pumped it over to the drain, and I've had no problems with that one since. And the one on the right, we just ran it straight over the drain, literally right in front of the furnace. And that one must not have been when I had the drain hooked up yet.
Is this where the condensation comes out right here, or is it just?
No, that's the drain for the tank. The condensation comes out behind the exhaust, which is the back.
Oh, I gotcha.
The back PVC comes out at the bottom of that.
Okay.
But just draining it straight down and away. I wouldn't recommend doing vinyl tubing unless it's going straight down, because the vinyl tubing will hold the water. Gotcha.
But yeah, it was that one was kind of interesting. Just the amount of condensation that you'll have to deal with is higher. So basically, this thing's like, it's kind of a hybrid between a regular tank, storage water heater and like a boiler system. Like, you can see the heat exchanger on it. Looks a lot like a boiler. And then Mark said it's fully modulating. So it will kind of, what does that mean? Is it basically adjusts based on, it adjusts how high the burner is based on what the need is and what the demand is?
Yeah, based on what the need and what the demand is and how long it's going to have to run, it'll modulate.
Gotcha. And what's your sister's experience with this 20 gallons of warm water?
So the 20 gallons of warm water, hers, like I said, it does 160, but she can do 3 showers, a load of laundry, and a dishwasher, and they have yet to run out of hot water. And they've had theirs since January, and they've really liked it. So when we put one in here at Bragg, I was interested because I was working on hers, and I didn't even have time to go out and put the cover on the cover on the outside, the wall kit, and it had already shut off. So I was interested when I installed one here at Bragg, how long from cold water, 60 degrees, to 160 degree water, 20 gallons, it ran for 6 minutes and 17 seconds.
Wow. So you just hooked one up, filled up the tank, and then you timed it from when you fired it up to when it stopped heating. And it was 6 minutes.
6 minutes.
Wow.
And so she's done that. And then I don't have the numbers or anything like that, but she said her gas bill has gone down from not having, obviously, no pilot light and it not having to run as much.
Gotcha.
I don't have the exact numbers, but I did ask her if her gas bill has gone down, and she told me it has compared to this time last year.
Nice. Yeah, and that's from the literature. They do claim there's a little bit of energy savings because they are more efficient. Oh, this was your CO, your combustion tape on it. And
it's firing at 98% efficient, which is for a water heater is crazy.
Yeah. And then your flue temps are nice and low. So just kind of an interesting solution. Does anybody out there have any specific questions on this one? Anything Mark can help you with or that we can talk about? I'm not seeing anything in the chat.
Is it possible to common vent that with a 95% furnace? If you use like 3-inch PVC pipe?
Can you common vent those at all? I don't even know. I don't think you can you?
No, I don't think you could at all.
No, that's not an option.
Yeah, I would think you'd have some pressure issues. But you do, like they do have a 3-inch, it's set up for 3-inch, and you can go around 100 feet on the venting with 3-inch. So, and then obviously a little shorter with 2-inch. But yeah. Other questions? So again, it's just the HTP, and the thing I liked about it was the price tag, like especially where the state of Utah is now low NOx. So this one's the ultra low NOx compliant, and if you're comparing this to a regular sealed combustion water heater, you're a little bit cheaper on this. It is a smaller outfit, but I thought it was really interesting, and that's they're instead of heating the water up to 120 degrees like you do with a normal storage tank water heater, they're heating up to 160 like a boiler and then running it through a mixing valve so that it brings the temperature back down. So in essence, it's like you have a bigger tank already, and then because it's heating the water with the heat exchanger like a boiler, it has a really fast recovery time, and you get some of the efficiencies that you get from a tankless. So kind of a cool solution. I think they had like a 6-year or a 3-year and a 6-year warranty on them and stuff. But anyway, if you guys check them out if you want, I found their info just at that htproducts.com. And Mark, you said Peterson Supply was where you guys were buying them at?
They have Logan, Ogden, Salt Lake, Richfield, and Cedar City, so they're pretty all over. But I mean, go in there if you have any questions and talk to them about them. They're pretty good about talking to you about them, and they'll give you some info on how to get a hold of their reps if you have any other questions.
Cool. And then, just one last thing on that condensation. When we talk about high volumes of condensation, you mentioned that before you got the condensate pump corrected at your sister's house, she had to empty a 1-gallon ice cream bucket how often?
It was every other day she was emptying a 1-gallon, and that was just what was leaking, plus what was still going down the line before I corrected it.
Gotcha.
So I mean, it lets out a lot of condensation.
Yeah, so just be aware of it if you are doing a mobile home install. We probably don't want to be dumping a lot of, you would need to have a drain somewhere where that water could go, or some really well-draining soil or something, so we're not dumping a lot of condensation under a house. But anyway.
So would a good option for the mobile home just to do the pump and tie it into a drain with some heat tape so in the winter it doesn't freeze under there?
Yeah, that would be a good option for a mobile home as well. The one mobile home that we've done up here at Bragg was an old man and an old lady. I don't see him. We didn't see him using it that long, but we took and made a hole in the paper bear and everything and got it underneath there. So I mean, everything, look at the situation, because if that house would have had 4 kids and then 2 other adults, yeah, we probably would have wanted to pump that one versus letting it go underneath the house.
Yeah. Awesome. Well, thank you guys for thanks to Bragg for being willing to share. Thanks for Mark. And
Yep.
and you know, as you guys try this or any other options, you know, if you find something that's working, feel free to share. If you start using something like this or something else and you're running into problems, share those as well, because, you know, if we can get in front of stuff like that before it gets too big, we always like to do that. So anyway, all right, the last part of the meeting today is a worst case draft form. So I guess let me start here. So just a little bit of background on where we're at with worst case draft and why we need a new form. Basically, we have about a year and a half ago, our program adopted the BPI 1200 standard, and pretty much as wherever it was applicable. So, and then I think many of you are aware, as we have talked more and more about this standard, and as we've become more familiar with it, we've realized that our old worst case draft form does not really follow BPI's combustion appliance safety inspection, which is basically the worst case draft test. It doesn't really follow their process. And since we've adopted this standard, we had to take a really good look at this process. And as we've done that, we've realized we need to conform with this process, mainly because we've adopted it as a standard, but also, like, just from a programmatic standpoint, this is a really good standard. And so, yes, we adopted it. Now we understand it a little bit more, and yes, we still want to keep this standard. It's a great standard to use. We like it because it's a national standard. But basically, we're talking about our worst case draft test. One of the issues that we've run into is when you get inside of a home, if there's a couple of different doors, then you start to realize there's a number of different configurations you can put those doors in that can affect the CAS pressure. And if you do the math on a home with 6 or 7 doors, you start to realize there's actually thousands of configurations that you could put the home into. And since we don't have time to go into every home and run multiple configurations, we really just need a standard that is going to get us as close as possible every time to getting the right configuration for the home and depressurizing the CAS, as much as we can, but kind of in a standardized format. So that is why the BPI 1200 standard is so valuable. It allows us to go in and basically set up every house essentially following the same procedure every time and depressurize the CAS. In general, we'll be depressurizing the CAS as much as we can on most homes. From time to time, there will be some situations where following this process will not quite get you there, but there is a way to deal with that when you're aware of it. And then in the situations where you're just not aware of it, as long as you follow the standard, your clients are going to be safe anyway, because the standards it really takes care of most of the major issues. So anyway, what I have on the screen is BPI they wrote their standard and they kind of put it all together on this little quick reference card. And if you don't have a copy of the quick reference card, after today's meeting, when I send out the email that follows this meeting, I will include this quick reference card in that email. So make sure that you download that and that you have it available. But basically, BPI approaches the worst case draft test in not just like a draft test. They call it their combustion appliance safety inspection for vented appliances, and they're looking at venting or spillage at the draft. We want to make sure the appliances are drafting, but then they also have a standard for the amount of carbon monoxide that the appliance can have. And so as we've adjusted the worst case draft form, I'll show you in a minute, you'll see that it accounts for both of these things. But what I've done, we've tried to basically follow this process exactly as it is laid out in the BPI 1200 standard. So I won't read through any of this stuff here, but all I've really done with the worst case draft form is I've taken all of these steps and I've put them on the form in this same order. So if you use the new form, basically the new form is the instructions for the new form are this quick reference card. Like, you will be following BPI's standard and you'll use the new form to document it. So this is what the new form looks like. Hopefully it doesn't look too different from the old form. I've had to adjust a few things because of just space, but basically it's laid out a lot like our old form. Client's name up at the top, the testing stage. Down at the bottom you have your conclusion. And really the first part of the test here is where you're going to depressurize the CAS. And then the second part is where you're actually testing the venting and the CO. So, same format. Let me zoom in and I'll just kind of go through this depressurizing the combustion appliance zone. Now, as I'm doing this today, and then also in the next few weeks, what I would like your help with is to think about how this will really work in the real world, and please give me any feedback. If this is not working, or if we need to tweak or adjust this form in any way, I would like to know. My intention with this is that after the meeting today, I will send this form out basically it'll be a draft. And I would like everybody who runs a worst case draft test to please use this new form for the next month and give me any feedback. We'll ask for it. You can send it to me, email it to me, or call me or whatever during the month. And then basically at the next technical meeting, we'll take a couple of minutes just to gather any additional feedback on it. And then after June's technical meeting, if all goes well, we'll put this form out as the new official form. So anyway, as I go through this, kind of pay attention, think about how that might work. If you notice any flaws or if you have any concerns, then we want to talk about them though. Basically, I feel like for me, the biggest change in the worst case draft test going to the BPI 1200 standard is really the setup of the test. The way that I learned it a few years ago, the way that we've been teaching it is just a little bit out of order from the way BPI's standard is set up. So that will be the biggest change for a lot of people, I think. And so I've put these steps on the form. And I've put the language right out of the BPI standard, so that when you're out in the field, if you can't remember exactly what you're doing, hopefully the language there will help. So step number 1, you're just simply putting all of the appliances. It says place all combustion appliances located in the CAS in their standby mode and prepare for operation. So I think we've gotten really good at that. That shouldn't be anything new. Number 2 might be a little bit of a change, but basically the standard says you're going to turn all the fireplaces off. We've had some discussion in the past where our fireplaces, they may be the primary source of heat, and we actually modified our form in the past to allow for that. And based on my last 3 years worth of monitoring, I have not seen anybody use that modified or the modification on the form. I haven't seen anybody using a blower door to simulate a fireplace in any situation in the last 2.5 years. So if there are any safety concerns about that, if you run into them, let's talk about it, because this is a draft, but if we're following BPI's standard to the letter, you just turn off all the fireplaces regardless of whether they're the primary heat or not. So fires in wood stoves and or fireplaces must be fully extinguished with no hot coals or embers. Close the fireplace dampers and any fireplace doors. That's all you got to do with fireplaces. Number 3 is just setting up your exterior doors and windows. You're going to close all building exterior doors and windows, and it says to leave outdoor openings for combustion air open. Number 4 is important. This one's kind of a bigger change for me. At step number 4, you need to close the CAS doors. And so for any auditors or anybody, anybody who's auditors, QCIs, production guys that are running this test on a regular basis, you may need to make sure you have equipment that is Wi-Fi enabled so that you can close the CAS doors and still get the readings that you need while you're doing the rest of the setup and the rest of the test. Number 5, this one's kind of important. I think some of you have a little bit of an idea what this is about. If you don't, we can provide additional training. I know Dalton has been showing a lot of people how to do this and what this means, but basically their standard says that you close the interior doors of all rooms except for rooms with an exhaust fan and rooms with central air return. So you walk through the house and you close all of the interior doors except for rooms with an exhaust fan or a return air. So you typically leave all your bathroom doors open if they have an exhaust fan, and then if you have a room, usually that larger room has the centrally located return air. But if you have other rooms that have a return air in them, then you're going to leave the door open. And that's all you do for step number 5. You just walk through the house and close or open doors. Step number 6, you're going to make sure all of your mechanical ventilation is off. And then, so it says turn off any mechanical ventilation, forced air, or cooling or heating system blowers. Step number 7, this is where we actually start recording stuff. So now that you have the house all set up, step number 7, you measure and record the baseline pressure in the CAS with reference to the outside. That's the worst case draft test as we know it. This is just starting pressure. So you just put in whatever your starting pressure of the CAS is. So you might be starting out a little bit positive, like with a 1.2. Step number 8, you're going to turn all of your exhaust equipment on. On the old process, there was a step where you'd turn on your exhaust fans and a separate step where you would turn on the dryer. On the BPI standard, you just turn everything on at once and then you take a measurement. So it says turn on the clothes dryer. You're going to check for a clean dryer filter and make sure there's no blockage. You're going to turn on any range hoods, any other exhaust fans. And there's there's 2 notes here. You're going to operate the exhaust equipment at its highest speed. And also a note that says do not operate a whole house cooling exhaust fan. So I've seen a couple of homes with these giant fans like that, and so the standard basically says don't turn those on as part of this test. And then you're just going to measure and record it. So maybe by doing that, we're going to go a little bit negative, so we might be down to a 0.9 or something. And then the next step is, so you've got all of your doors configured right, you've got your CAS doors closed, you've got all of your exhaust equipment on, and now we're going to turn the air handler on. And for step 9 and step 10, I've put this note here, but because of lack of real estate on the form, I just put, for number 10, it's the same as number 9. So when you turn on the air handler and then when you're messing with the CAS doors, basically it says determine and indicate the condition above that causes the greatest CAS depressurization. So now you're basically turning on the air handler and you're seeing, well, was it more negative with air handler off or on? And so you're going to, once you've determined which one causes the CAS to go more negative, you're just going to indicate that it actually went more negative when it was on, and then you're going to document how negative it went. So we'll say it went to like a negative 2.3. On step number 10, for the CAS doors, so they're already closed, so now you're going to open them and you're going to see, does the CAS go more negative or positive? Well, let's say in this case I opened them and it caused the CAS to go from like a negative 2.3 back up to just a negative 1, so it made it go more positive. So that would mean that it's more negative if I keep the doors closed, and so in that case I'll close the door back up, and it should cause the CAS to go back to a negative 2.3. So you would just simply document that. Number 11, this is where we plan to provide additional training. This is where if you feel like you haven't quite got the doors in the right position, you can do some additional testing. And that is, I think Dalton has shown some of you this pressure differential diagnostics. Basically, it's just where you throw a hose underneath the bedroom door and you determine whether the door should be open or closed. So there's a spot on the form to do that. And let me just read what the standard says. The standard says alternately, pressure differential diagnostic may be used to determine proper door configuration to create the greatest CAS depressurization. And then it says you're going to list the door positions that were adjusted based on the alternate method in the field below. So you'd use this space right here. If you changed any door configurations, you'd just say, you know, we closed the door at the top of the stairs or something like that. So you'd list that below, and then you'd measure and record the greatest depressurization in the field above. So let's say that there was an alternate door, like you felt like, well, there is an exhaust fan in the bathroom, but the supply, you feel like the supply might be pushing out more than the exhaust. So you measured it, and so instead of leaving the bathroom door open, you found that when you closed the bathroom door, it caused, you know, it was more positive in there, which means it causes the CAS to go more negative. And so, you know, it might push the CAS down to like a negative 2.5 or something, and you would just simply note that hall bath door closed. So really just a couple of quick notes, and you should be, you know, have everything recorded that you need. Now with the alternate door positions, this is BPI standard. That they basically just say if you want to, you can do this. In our program, we are going to require that anytime you have a home that has, we're calling them central partitioning doors. These are going to be doors that would divide the dwelling into 2 or more zones that have multiple rooms. An example of this is the door at the top of the stairs. So if you close, there's kind of that door it's going to divide off like half of the house, or it's going to divide the top floor from the basement or something like that. Anytime you have that door that can actually be opened and closed, you are required to actually do the pressure differential diagnostics. You're required to close that door and see what it does to your CAS pressure. And if it makes it more negative, then you're going to, well, actually either way, like if you have a door at the top of the stairs, and during this whole test that door has been open, and then you get to this point, you would still need to note like door at the top of the stairs left open. So you're just going to record whatever you're doing with your central partitioning doors. So I tried to draw a quick sketch of like a house with a, you know, that's not a basement, but let me just throw this up on the screen really quick. So this is just my computer's not liking things here. Okay, so this would be like this square right here is kind of a house, and then I've been in a number of these where they've added on an addition or something over here. And so this wall right here used to be an exterior wall, but now they've added on like a new living room and a bedroom and another bathroom or something over here. So this door between this part of the house and this part of the house, it represents a central partitioning door. So if you close that door, you now have 2 zones with multiple rooms. You have this zone with multiple rooms, and you have this zone with multiple rooms. And then I've put a note on the form, which I'll go back to in a second, but basically, when you're testing this, you need to be on the side of the door that's closest to the CAS. And so this is a really bad drawing, but if this was a manometer and this is the CAS over here, you're going to be on this side and you're going to be referencing that other zone that is furthest away from the CAS. So just bear in mind that's how that test is done. If you need additional help on that or training, just let us know, and we can help on the phone. We can schedule some time to come and spend some time with you or with any of your team members who need that help. But so it's required on central partitioning doors, and then just this note that says the pressure differential test should be the zone with reference to the CAS. So in this picture, the hose is the input, so the hose is the zone, and then the reference port on your manometer is with reference to the CAS because you're over here in the space that's more connected to the CAS. So, and then that's it. Once you've done all of that, then you should have the combustion appliance zone in its worst case pressure. So we figured all that out, and now we know we're at a 2.5. Does anybody have any questions on this first part of the test? Now we're at the 9 o'clock mark. The next part of this is only going to take about 3 or 4 minutes, so if you guys can, if you'll just hang on for the next few minutes and then we'll end. But if you've got to drop off, I understand. So once you have the CAS in worst case, then this next part really should look very similar to what you've dealt with in the past. There are a few changes, though, to align it with the BPI standard. Over here, you're just simply indicating which appliance you're testing. On the form, I've actually added a drop-down list that just says water heater or furnace, and then you also have the ability to type in whatever you want. So if you want to put water heater 1, or if there's something else going on, you can do that. But I'm hoping for some of those on a tablet that might just make it quicker to fill out the form. But there's a note here, and this note really only applies when there is a shared or a common vent. But if you'll just get in the practice of doing it all the time, then you won't ever get it wrong. But so just a reminder to test the smallest BTU to the largest. So you're going to always start with the appliance that's the smallest BTU, and then you're going to kind of test toward the largest. So let's say we are in a CAS. We'll keep it really simple. We're in a CAS that just has a water heater. The furnace is like a 90% efficient furnace. So the only appliance in there that is a Category 1 appliance that has a natural draft is a water heater. So that's the only one we need to worry about testing. The next thing you got to determine is your vent temperature. And the BPI standard actually has 2 different time limits. They say if it's a cold vent, then you're not going to measure your vent pressure or spillage until 5 minutes. Or if it's a water heater or a warm vent, then you'll measure spillage or vent pressure at 2 minutes. So I put those here, and I put cold 5 minutes and water heater or warm 2 minutes, just so that you have the standard right in front of you. When you're filling out the form, you will have to indicate, okay, this is a water heater, and so when I measured my vent pressure, that was at 2 minutes. So you would fire the water heater, you would wait until the 2-minute mark, and then you would record your vent pressure. So we'll say our vent pressure is a negative 0.5. Or, sorry, we'll go we'll do a negative 0.5. That's fine. The other part of this test that is going to be new is that BPI now says while the appliance is in worst case, or the CAS is under worst case, you also need to check the CO, and you need to do that at the 5-minute mark. So the next thing is what's your CO at 5 minutes, and it's 99% of the time it's air free. I think only when it's a oven, and I can't imagine how often you'd have an oven in your CAS, so I put right on the form CO at 5 minutes, parts per million, air free. So you're going to measure what that is, and you're going to say, okay, we've got CO. Let's say our CO is at, let's say it's a little high. It's at like 205. And now that you've measured that, now you have to determine whether or not the appliance passed this test. And in the past, it just said, was this an acceptable draft? But now the form says, is it acceptable draft and CO? So question to you guys, did this appliance pass this test?
What's the minimum supposed to be?
What is the minimum supposed to be? Does anybody know? Or want to venture a guess?
200 parts per million.
So you're talking about CO.
I was
Yeah.
talking about vent pressure because your calculation's not on there anymore.
Yes.
Yeah, because they would depend on the temperature of the day.
Okay, so let's address what Shad's saying. So if we're talking about CO, we have to reference the EPI 1200 standard, which says water heater is 200 parts per million air free. So based on what Shad's talking about, this does not pass. This fails the test, right? Now I'm going to change that just for our just for the sake of demonstration. Now if it's 190, now does it pass the test? How much pressure do we need in our vent now? The answer is yes, it passes the test. So BPI 1200 standard, they do not use a minimum draft pressure. They just simply say, is there spillage or not? So if the vent pressure is positive, then there's spillage. If the vent pressure is negative, then there's not. That's all it is. That's how you make the determination. And so, again, we've adopted this standard. We feel like it's a good standard. We're going to use it. But I think that's going to be the biggest change. You no longer have to calculate your minimum acceptable draft. You're really just determining what the vent pressure is at the 2 or the 5 minute mark. And you're documenting it and determining whether it passes or fails. So now the normal case, the BPI 1200 does not speak to like doing the test under normal conditions. But I've left that on here, and you guys can give me some feedback on that, whether we want to leave it on there or not. My thinking is that if you found an appliance where you're okay on the CO, but it's not drafting, if you'll go back and test it under normal conditions, it may allow you to leave that appliance in service until you can come back next week. And so I kind of like that practice that we've had the ability to do that, and so I was thinking to leave that on there. But you guys try it out and give me some feedback on it over the next few weeks. But basically, you know, if you can see, oh, under normal conditions with the CAS door open or closed, and you know, not this weird configuration that we just put the house in, it'll vent, and our CO is maybe, you know, 25 or something. So you feel comfortable, you can leave the house or you can leave the water heater on, then you can write that into your corrective action plan, and you've documented up here that, yeah, it failed, but we left it in service because the client agreed not to close this door until we come back or something. So, and then just really quickly, the last thing on this, the rest of this form is exactly the same, except for there are a couple of words changed up here. So this first one, under the conclusion, so once you've done the test, you need to write a written conclusion. You're going to say this test was not applicable, or we passed the test, or we failed the test, and this was our corrective action. The situation where it's not applicable, the first one is the same, that if you went to the house and there were no combustion appliances in the dwelling, it's like all electric home, then you'd check this box and there's no testing required. for auditors, the first time you go to the house, you're going to fill out this form no matter what. If the auditor finds that it's an all-electric house, you check this box, you put it in the file, and nobody after you has to fill this out unless you guys were to install a combustion appliance like a Category 1 combustion appliance after that. So you check that box. If it's not, then at some point during the process, or like if you got there and all the combustion appliances are not Category 1. Now, I'm using this term Category 1 and Category 4. Basically, a Category 1 is a natural draft appliance, and a Category 4 is what we're seeing. It's the sealed combustion appliances that we're dealing with. So the next one says, and that was the language that changed. Instead of saying, a direct vent appliance or something, we've changed it to the correct terminology. So one of the conclusions would be that all combustion appliances are Category 4 and no further testing is required. So if that was the case, you could check that box. Now, you could have where the auditor goes out and they find that there was some Category 1 appliances, but somewhere in the process, you swap those out for Category 4 appliances. And then whoever does this test after that has happened, they would then check this box and say, okay, now all the combustion appliances are Category 4. So no further testing. And then after that, you no longer have to do the combustion testing or the worst case draft testing. The other option is just pass. All Category 1 appliances are venting safely under worst case depressurization, and this is the extra language, and are within the CO thresholds. So make sure you're putting both of those pieces together on this when you're doing this test. And then fail one or more Category 1 combustion appliances, fail worst case draft test, and then you're going to write your corrective action plan. The corrective action plan has not changed at all. So the rest of this test should be pretty normal. So anyway, those are the changes that I made. Is there anything glaring on this that you guys are concerned about, you want to talk about for a minute? Or does anybody have any questions about it?
So am I to understand there's no minimum draft now, as long as it's a negative, it passes?
You are correct.
Okay.
Yeah, and it is off the form. So yeah, it just has to be venting.
So like a negative 0.1 is a pass.
Yes. Now, if you guys get to that, if I saw on a note that you replaced an appliance because of a weak draft, and I saw that you had a negative 0.1, I'm comfortable with that. But yes, if you went the other route, like you guys can make a decision at that point. So if you're feeling uncomfortable with something, you can address it, but we are going to follow this standard, and as negative 0.1 is drafting. So that passes this standard. The thing that I like about this is I feel like where we are putting these homes into this worst case draft test and we're cranking on these big exhaust fans and stuff, sometimes we do get to where it weakens the draft, but really most of the time that house is going to have a nice strong draft. And when we put it into worst case, yeah, the draft is weak, but it's still drafting. So, this will actually help us. I feel like we've gone into some homes and kind of been like, oh, there's this important thing we have to change in your house, and the clients are like, oh no, have we been unsafe? And really they haven't been unsafe. We're just being extra safe or extra cautious. So this, yeah, I feel like this gets us anyway, we're still very, very safe because where we're doing ASHRAE fans and everything else, if it's just weakening the draft, as long as it's still drafting, they're fine. So anyway, other questions? Cool. Well, sorry to run over, but thank you for your attention and your time. And then, yeah, just remember, send me feedback as you're thinking about it, as you're using this form, and then, be prepared to talk about it a little bit next month. If you guys feel like you need additional training on it and stuff, let us know, and we can schedule it and plan accordingly. So anyway, let's go ahead and end the meeting. You guys have a great day. Thanks for all you do.
Thank Thank you.